Hello everybody and welcome to this video on upgrade strategies for Charm Kubernetes. My name is Calvin Hartwell and today I'm going to be talking to you about 3 different strategies you can take to upgrade your Kubernetes cluster. The in-place upgrade strategy essentially uses a cluster and upgrades it in place. It only requires a single cluster, doesn't require any additional capacity or additional software or services to perform the upgrade. The second strategy is known as blue-green. This is functionally similar to the previous strategy, however it allows us to keep the workload running and doesn't have the outage as the previous one does, but it does require some additional capacity for additional workloads, however it's temporary. The third strategy is the cluster-to-cluster upgrade strategy. This is the safest option, however it does require a lot more capacity because we essentially will spin up 2 clusters, one running version n and the second cluster running version n plus 1 or n plus 2 for example. The idea is that you will migrate the live workload and then destroy the old cluster afterwards. So in-place upgrade. It's definitely the easiest and fastest to do. This is probably applicable to most customers who can tolerate a few seconds or a few milliseconds of outage. It's perfect for things like dev and test environments where outage for a few seconds doesn't make any difference. It's completely automated by the tooling that we have today, which is Juju. It doesn't require any additional resources. So for example, if you're on bare metal or in a really resource-constrained cloud, VMware environment, OpenStack Cloud, and there's definitely no resources available for additional VMs, this is definitely the upgrade strategy you'll have to take. So let's see how it's done. So before we begin the upgrade procedure, I just want to point out the fact that the documentation that I'm using to perform this upgrade is on our website. So it's on ubuntu.com/kubernetes/docs. I would strongly recommend before performing an upgrade you check out the release notes and the upgrade procedure for the particular release that you're using of Kubernetes, as it may change from release to release. But everything I'm performing in this demo can be found there. So on the terminal here, you'll see a couple of different screens. The top hand, left-hand side there is Juju, so I have a cluster deployed already with Juju, and I just have the Juju status output so we can see what's going on as I perform the upgrade. In the middle section there I have some HTTP pings running. Essentially what this is doing is, the one on the left-hand side is checking a workload that I have deployed on the cluster to see if there's any outage. It's just a simple Nginx-based workload, and then which is being provided through the ingress controller. And then on the right hand side I'm pinging the Kubernetes API endpoint, which is provided through the Kubernetes API load balancer. And then at the bottom I have the kubectl get pods output, and the interesting thing about this output is it actually shows us which worker node is running it. I have 5 replicas for my workload, which is called vanilla here. It's just a very simple workload, as I mentioned, but this output may also change as we start to do things on the cluster as well. So this is quite interesting to look at, particularly with the blue-green upgrade strategy, as we'll do in a second. So what I'm going to do is I'm just going to run the first upgrade. First things first, I'm just going to upgrade the Kubernetes master channel. So that's done, very easy. Now I'm going to upgrade the Kubernetes worker channel. So if you're not familiar with charms, charms are essentially modules of code which handle the operations for a particular service. So there's a charm for things like etcd or Kubernetes worker, master, the load balancers, also the CNI plugins, and also workloads on top of the cluster. So what we'll see now is in the Juju output that it should be performing some actions. Here you can see here that it's started to upgrade the charms. So what we're essentially doing by upgrading the charms is we're upgrading the operational code that handles these services. This is separate to the binaries for the services, which is what we will upgrade next. Interestingly, you could see here that there was some dropped packets there. As I upgraded the master on the worker node, there was some outage. However, in general, the outages are minimal. I have done both the master services and the worker services together. However, you don't have to do that. You can do them one after another if you wanted to. So we can see the workload has come back now. So now what I'm going to do now is upgrade the channels. So I've upgraded the master channel. So I've upgraded this basically to 1.21. We were running 1.20 before. The workers. So with these particular, when you change the channel to the next release, this is essentially changing the binaries. This is setting the snap channel. This is changing the binaries which we use for these processes. As you can also see on the left hand side, it's actually put this into a block state. That's because I need to then run the upgrade actions, which is what I'm going to do next. We may also start to see some more outage on some of the services while I do this. So you can see at the bottom here, the API endpoint has become unresponsive. The Kubernetes API load balancers are just running a simple load balancer, so should return in a second. One thing I haven't done as part of this procedure is actually to upgrade etcd or the Kubernetes API load balancer. It is totally possible to upgrade these as well. It's just a few more commands as per the documentation. But in order to upgrade the Kubernetes release, you don't actually have to do that necessarily. There we go. One of the masters has successfully been upgraded. The second one should follow suit very quickly. And yeah, that's basically an in-place upgrade. There we go. It's upgraded. That's basically an in-place upgrade procedure, end to end. The next strategy is the blue-green upgrade strategy, and this one essentially is functionally similar to the previous strategy. However, it does require additional worker nodes. The idea being that we will essentially deploy the latest version of the worker node services, so version n+1. We'll migrate our workload and test the workload on those new machines. Then we'll essentially remove and destroy the old worker nodes as they're no longer required. This not only allows us to test that the new worker node version is fine with our containers, but also allows us to mitigate this issue of workload outage. We essentially will not have any outage in the workload with this strategy. So this is perfect for customers who cannot tolerate any outage of their workload, or if there's a critical update that you need to make during business hours, for example. This is definitely what you'll have to do. Finally, we come to the cluster-to-cluster upgrade strategy. I'm not going to be showing a live demo of this strategy. However, it essentially works by having two clusters, where one is running cluster version n and the second is running cluster version n+1. The idea is that you would use a piece of tooling such as Valera, which is used to be Heptio Arc. The idea is that you'll migrate the workload plus all of the persistent volumes and any other configuration you have on that cluster to the new one. You'll then test it, and then you'll destroy the old cluster while basically retaining the new one. This is definitely the safest option. You know, you're not tampering with the existing cluster. You have a completely separated environment. It is complex though. It's not as simple as the other two options in that you have to migrate everything like the storage and the containers and the workload first. In order to do this, you also have to transfer any DNS records, load balancers and so forth to actually make sure that everything's functionally the same. It also requires a lot more resources. You'll have to basically deploy two clusters. So rather than just deploying worker nodes, you're having to deploy everything including etcd, the master services, Kubernetes load balancer, and so on and so forth. However, it is a lot safer. So thank you for watching. If you have any questions, please feel free to send us a message, or you can write on Discourse. Thank you very much.